Okay, so we're looking at number 4 here. Sven, Tina, and Lori can process 740 telephone orders per day. Sven and Tina together can process 470 orders, while Tina and Lori together can process 520 orders per day. How many orders can each person process alone? So the first thing I did here was I named my unknowns. I used S, T, and L because of the names. You can use anything you want. You could use X, Y, and Z. I like to use the letters of the names because it helps me to build the equations more quickly. So because there are 3 unknowns, we do need at least 3 equations to solve for all of them. The first relationship can be gotten from this first sentence. It's telling us that if all 3 of them are working together, they can process 740 orders. So S plus T plus L should equal 740. The next sentence gives us 2 more relationships. Sven and Tina together can process 470 orders. Tina and Lori together can process 520 orders. So I've gotten 3 different relationships from the problem. So now looking at the system, there are lots of ways you can solve this. Looking at this, I think I can do elimination. So let me go ahead and label these equation 1, 2, and 3. What I think I want to do is take equation 1 and add it to -1 times equation 2. If I do that, I believe I can eliminate S and T and then immediately solve for L. So let's try that. So here's equation 1. And here is -1 times equation 2, and I'm multiplying both sides by -1, distributing. Everything gets multiplied by -1. I'm adding these together. So you can see that the S and the T get eliminated. And I'm getting L equals 740 minus 470, 270. So now I have L solved for. So what we can do now is take that L and sub that into equation 3. So let's do that next. So I'm using equation 3 here. I can replace L with 270. So I have T plus 270 equals 520. So I can solve for T by subtracting 270 from both sides. So T equals 250. And lastly, we want to solve for S. So if I go back to equation 2 and replace T with 250, I can solve for S. So I have S plus 250 equals 470. Subtracting 250 from both sides, I get S equals 220. So we've solved for S, T, and L. So let's go ahead and write out what the answer to the question is. They bought, I'm thinking of the next one, alone. Sven can process 220 orders. Tina can process 250 orders, and Lori can process 270 orders. Okay, let's go ahead and try the next one as well. Students in a music appreciation class bought 40 tickets for a piano concert. The number of tickets purchased for seats in either the first mezzanine or the main floor was the same as the number purchased for seats in the second mezzanine. First mezzanine seats cost $52 each, main floor seats cost $38 each, and the second mezzanine seats cost $28 each. The total cost of the tickets was $1,432. How many of each type of ticket were purchased? Okay, so you can see here I did the same thing as the previous one. I chose letters to represent the unknown quantities, the number of tickets for each type of seat. Now we need to create 3 equations from the problem. Once again, the first sentence gave us a total. They bought 40 tickets total, so if I add these up, I should get 40. then the next equation gives us another relationship. The number of tickets bought in the first mezzanine or the main floor adds up to the number of second mezzanine seats. So F plus M equals S. The last relationship has to do with money. So the total brought in from the tickets was $1,432. Well, each first mezzanine seat cost $52, so 52 times F, plus each main floor seat cost $38, so 38M, plus, and then each second mezzanine seat costs $28. And then we have the total, $1,432. Okay, so I'm looking at this, trying to think of how I want to solve it. I think we could get S right away. If you notice here, we have F plus M here and here. So I can replace this F plus M with S. This will be a substitution. So I will get from here, S plus S equals 40. So I have 2S equals 40. So S is 20. So now I already have S solved for. What this means now is I can take two of these equations, replace S with 20, and then I'll have a 2 by 2 system that I can solve for F and M. So I'm going to do that for these last two equations here. I'm going to replace S with 20 and rewrite the equations. So here I would get F plus M equals 20. Here I will get 52F plus 38M plus 28 times 20 equals 1,432. So let's go ahead and multiply that out, and then we'll ultimately subtract it over. What is that, 56? 560? Okay, so 1,432 minus 560. So I have 52F plus 38M equals 872. So let's label these. I'm looking at these two equations now. I'll say this is equation A. This is equation B. So equations A and B give me a 2 by 2 system that I can solve using substitution or elimination. I think I will just do elimination. Doesn't really matter which one. I guess I'll eliminate M. This has a 38, so I'm going to make this one have a negative 38. So I'm going to take equation B, and I'm going to add it to negative 38 times equation A. So that means that I'm going to multiply every term of equation A by negative 38. So let's do that right below. So I have 52F plus 38M equals 872 plus. Now I'm multiplying negative 38 by every part of equation A. So I'll have negative 38F minus 38M equals negative 38 times 20, negative 760. So by doing this, I've eliminated the M terms. So 52 minus 38, 14F equals 872 minus 760, 112. So we can divide that by 14, and I have F equals 8. Okay, now that I have F equals 8, I'm going to go back to using equation A and just replace F with 8. So here's equation A. So it's 8 plus M equals 20. Subtract 8 from both sides, M equals 12. So now I have all three unknowns solved for, so let's put it together in a sentence. They bought 8 first mezzanine tickets, 12 main floor tickets, and 20 second mezzanine tickets.